Hello students, in this video we are going to discuss question number 21 to 30 of atomic structure from Problems in Physical Chemistry for JEE Mains and Advanced by Narendra Avasthi. In question number 21, if radius of second stationary orbit in Bohr's atom is r, then radius of third orbit we have to calculate. Okay, so we can say that r equal to 0.53 n square by z. Here n is constant, so r of second orbit divided by r of third orbit will be 4 by 9. So this r2 is given by r, so you can write r by r3 4 by 9, or r3 equal to 9r divided by 4, which is 2.25 r. So for question number 21, option D will be the correct option. In question number 22, which state of Be3 plus has the same orbit radius as that of the ground state of the hydrogen atom? So ground state of hydrogen atom can be calculated as 0.53 n square by z, that is 0.53. Now this 0.53 is equal with 0.53 n square divided by z, because this is Be3 plus. So from here we can calculate n square as 4 or n equal to 2. So the n value is 2, that is option B will be the correct option. In question number 23, select the incorrect graph for velocity of electron and an orbit versus z or 1 by z or n or 1 by n. Okay. Now thing is that v is directly proportional to z but inversely proportional to n. So v equal to k z by n should be the proper function we have to plot. Now if we plot v versus n, it will be a non-linear graph like this, so this is correct. If we plot v versus 1 by n, it will become a linear graph y equal to mx type. If you again plot v versus z where n is constant, so it will also give a y equal to mx type graph. But v versus n cannot be a linear graph because v is inversely proportional to n. That's why v versus n should be a non-linear graph like this. So we have to find the incorrect graph, and option D will be the correct option. In question number 24, what is the frequency of revolution of electron present in second and Bohr orbit of the hydrogen atom? Okay, so frequency is revolution is 1 by time period, and time period can be calculated as 2 pi r divided by v. So here time period for the second Bohr orbit you have to calculate, that is t2, 2 pi r2 divided by v2. Now frequency can be written as v2 divided by 2 pi r2, or it can be calculated as 1.082 multiplied by 10 to the power 6 divided by 2 into pi into 2.12 into 10 to the power minus 10, which will become 8.2 into 10 to the power 14 second inverse. So option D will be the correct option. In question number 25, an electron travels with a velocity of x meter per second. For a proton to have the same de Broglie wavelength, the velocity will be approximately, so lambda equal to h by mv. Okay, but h is Planck's constant. So if wavelength of electron should be wavelength of equal to wavelength of proton, so you can write h by meve equal to h by mpvp, or you can write that meve equal to mpvp. So vp can be written as me divided by mp multiplied by ve. Now according to the problem, ve is x and proton is much heavier than electron, so x by 1840 will be the final answer. So for question number 25, option B should be the correct option. In question number 26, according to the Bohr atomic theory, which of the following is correct? So if we calculate the frequency of revolution, it will become 1 by time period, and time period is nothing but 2 pi r divided by v. Okay, so now As we know that time period is directly proportional to n cube by z square, then frequency will be directly proportional to z square by n cube. So for question number 26, option C should be the correct option. In question number 27, the number of waves produced by an electron in one complete revolution in nth orbit. So this is nothing but 2 pi r equal to n lambda, where n is number of orbit. Okay, so n will be the number of lambda or wavelength. So in nth orbit it can produce only number of lambda, which is n. So option A should be the correct option. In question number 28, the electronic transition in helium plus ions takes from N2 to N1 shell such that we have two relations given. To solve this question, we can write 2N2 plus 3N1 equal to 18, 2N2 minus 3N1 equal to 6. So if we add this to 4N2, it will become 24, or N2 will become 6. Now we can write that 2 into 6 plus 3n1 equal to 18, or 3n1 equal to 18 minus 12, that is 6. So n2 will become 2. Now the electrons are coming from 6 to 2, so we can write that number of possible transitions 6 minus 2, 6 minus 2 plus 1 divided by 2, so it will become 4 into 5 divided by 2, or it will become 10. So option D should be the correct option. In question number 10, we can calculate R nu bar or wave number by Rz square within mod 1 by n final square minus 1 by n initial square. So it is a hydrogen atom, so Z value should be 1. So we can write R 1 by 2 square minus 1 by n square. So we can write R 4 n square minus 2 square. So you can write R divided by 4n square. So according to this, for question number 29, option B should be the correct option. In question number 30, the multiple of fine structure of spectral lines in due to, this is the presence of the sub energy levels of suborbitals or subshells. That's why option B should be the correct option for question number 30. Thank you for watching.